If you're new with Mercedes-Benz, welcome. If you've been with us for some time or are just now moving into sales, congratulations. In either case, we're sure you're excited about having the opportunity to sell the finest production automobile in the world. Not only will the job provide an interesting personal challenge, but the rewards can be substantial. As a Mercedes-Benz sales consultant, your ongoing training will consist of product seminars, sales techniques programs, and special videotape programs which deal with special interest subjects. And with all of this in mind, we hope to give you the information and knowledge you need to successfully sell Mercedes-Benz automobiles. This program is the first step in doing exactly that. The objective here is threefold. First, we'll introduce you to the company and give you a brief look at Mercedes-Benz history. Second, we're going to give you an overview of the model line as the first step in helping you understand the strategic positioning of the cars. By the way, 1990 is an important year for Mercedes-Benz for several reasons. First, we're bringing to market a totally new SL Coupe Roadster. Plus, we're introducing for the first time in the North American market two four-wheel drive vehicles called the Mercedes-Benz 4MATICs. In addition, there are four new engines, a 24-valve six-cylinder and a 32-valve V8 gasoline engine, and a 2.5 and 3.5-liter diesel engine. Finally, we've just completed a facelift on our 300 class automobiles to give them a sleeker, more aerodynamic look outside and a more luxurious environment inside. Once we've covered the product, we're going to spend some time talking about Mercedes-Benz engineering and manufacturing. We'll get into quality, safety, suspension systems, ergonomics, and power plant. Finally, we'll spend a good deal of time on basic selling techniques. You're going to discover two important and singular features that are unique to Mercedes-Benz automobiles. The first is that in the cars themselves, you've got products that can be presented and sold for what they are, namely an extraordinary line of automobiles. As you master the product knowledge, you will find that half the fun of selling these cars comes from impressing your customers with the lengths to which Mercedes-Benz engineers have gone in order to make Mercedes-Benz automobiles truly distinctive. A second, because the products are considered by many to be clearly superior to their competitors, you'll find that Mercedes-Benz automobiles attract a totally different breed of customer from those you might have seen in the average showroom. Your customers will be primarily professional, affluent, knowledgeable, and they come into the dealership expecting to be impressed with the product. Our research shows that Mercedes-Benz sales consultants have received very high marks from their clients. Further, because of your association with Mercedes-Benz, most prospects are going to expect you to be different from the typical car dealership personnel. It's up to you to make sure that they're not disappointed. At this point, we're going to begin your introduction with a look back at the only automobile manufacturer in the world to have been building automobiles for over 104 years.
The Mercedes-Benz story is a story of quality, a story of a standard of excellence that began more than a century ago with the words of Gottlieb Daimler, Das Beste oder Nichts, the best or nothing. Daimler was first to see the wide variety of uses for the gasoline-burning internal combustion engine. The success of his first vehicle, a motorcycle, convinced him that by installing his engine in a carriage, he could finally replace the horse. At the same time, Carl Benz, unaware of the work being done by Daimler only 60 miles away, was developing his own vehicle. But while Daimler was installing his engine in a carriage, Benz was creating the world's first automobile from scratch. It was successfully driven in late 1885 and patented on January 29, 1886, which is the birthday of the automobile. Daimler's vehicle made its appearance a few months later. Daimler marketed his engines around the world and was especially successful in France, where the automobile caught on quickly. It was in France in 1894 that the first automobile race was held. The 78-mile event from Paris to Rouen attracted both steam and gasoline-driven vehicles and was the first of many open-road competitions that helped establish the practicality of the automobile. A Peugeot and a Panhard, both with Daimler engines, shared first prize. While Daimler sought new uses for his engines, Carl Benz concentrated on building cars. He was soon a dominant force in the world's infant auto industry. He considered this Victoria a perfected car. And the Velo became the world's first mass-produced automobile when Benz turned out 62 of them in 1894. By 1900, Carl Benz had built 2,000 cars and was the world's leading manufacturer. At the turn of the century, automobiles were, to a great extent, still playthings for the wealthy, and the annual Nice Automobile Week held on the Riviera late each winter gave them an opportunity to show off their vehicles. Austrian entrepreneur Emil Jelinek, who lived in Nice, was an enthusiast who liked power and speed. And he agreed to purchase 36 cars from the Daimler company if they would build a model that could compete in and win the Nice speed tests. Such a large order gave Jelinek certain prerogatives, one of which was to have the new car named after his daughter, Mercedes. Innovative and technically brilliant, the Mercedes dominated events at Nice and was hailed as the car of the day after tomorrow. We had entered the Mercedes era. To the public, racing continued to be the proving ground for the automobile. And the race of races during the early years of the century was the Grand Prix of the Automobile Club of France. At the 1908 Grand Prix in Dieppe, Christian Lautenschlager drove his Mercedes to victory while averaging 69 miles per hour. Benz cars finished second and third. In 1914, a 1-2-3 Mercedes sweep was greeted by silence from the French spectators as relations between the two countries were growing steadily worse. A month later, Europe was at war. When peace returned, there was a dizzying array of cars to choose from in every country. Mass production, already established in the United States, began to spread across Europe. In a Germany that lay in financial ruin, there were 86 automobile manufacturers, although few persons could even think of owning a car. For two giants of the industry, Daimler and Benz, the road to survival led to amalgamation, which was completed in 1926. The origin of the three-pointed star is clouded by time. Some say it began as Gottlieb Daimler's lucky star. Others say it represented travel on land, sea, and air. It now combined with the Benz wreath, and the name Mercedes-Benz appeared on a growing line of cars. Cars that rolled off the production lines in the 1930s allowed Daimler-Benz to survive this difficult period and remain a major automotive influence. While the decade began with the introduction of a moderately priced car that featured a revolutionary four-wheel independent suspension, cars bearing the Mercedes-Benz symbol continued to represent the ultimate in power, luxury, and quality. Racing added luster to the Mercedes-Benz name as Rudolf Caracciola, Hermann Long, Manfred von Brauchitsch, and others drove the legendary Silver Arrows to victory after victory. The 1930s saw another major achievement with the development of the world's first series production diesel passenger car. But the company's automotive progress came to a halt as Europe was once again plunged into war. On the day the conflict ended, Daimler-Benz had practically ceased to exist. But from the rubble would come a remarkable period of recovery and growth. In a world anxious to get back to the business of living, automobiles were much in demand, and Daimler-Benz set about doing what it did best, producing fine cars. By the early 1950s, new models were ready for the marketplace. To help re-establish the Mercedes-Benz name, the company returned to racing. A new generation of Mercedes drivers, led by the legendary Juan Manuel Fangio and including Sterling Moss and Carl Kling, continued the winning tradition. During the decades that followed, quality was the Daimler-Benz watchword, and the three-pointed star once again represented the best in automotive technology. As the demand for Mercedes passenger cars, commercial vehicles of all sizes and shapes, and industrial engines grew, so too did Daimler-Benz, spreading its production, sales, and service network throughout the world. From only 214 cars built in 1946, the numbers have grown dramatically. This year, more than 500,000 will roll off the assembly lines. The lessons of a century go into the making of every car, truck, and bus. The same hard work and attention to detail that started it all 100 years ago continue to make a Mercedes-Benz the world's most sought-after vehicle. As we enter our second century, we do so guided by the words of Gottlieb Daimler, words that best explain our standards. Das Beste oder nichts, the best or nothing.
In 1990, you'll be offering Mercedes-Benz prospects a choice of 16 different automobiles, each designed to satisfy specific needs and demands. The primary objective of this section is to give you an overview of the model line. First, however, we're going to take a moment to be sure you understand the meaning and definition of the model and body style designation numbers and letters.
Traditionally, the model numbers have represented the engine size. For example, a 560 is a 5.6-liter engine, and a 420 is a 4.2-liter engine. However, in recent years, there have been some exceptions. For example, the original European version of the 190E did in fact carry a 1.9-liter engine, but when it was brought to the U.S. market, it came equipped with a 2.3-liter engine. Today, it offers an even larger 2.6-liter power plant. In the 300 class, you have the 300E 2.6 and the new 300D 2.5 turbo diesel, which offer a 2.6-liter gasoline engine and a 2.5-liter diesel engine, respectively. However, since both automobiles share the 300 class body style, they bear the class number followed by the engine size. The letters generally describe engine types, body styles, and level of luxury features. For example, any car with a D is powered by a diesel engine. An E in the name stands for Einspritz and designates a fuel-injected gasoline engine. S is for the German word Sonder, which means superclass and tends to denote luxury appointments, features, and body styles. L indicates a long wheelbase. One exception is the SL. These letters are an historic holdover from years ago when Mercedes built a race car with a super light SL frame. The letter C designates the model as a coupe, and the T stands for touring or transport and identifies a station wagon. In your product training, you'll hear references like the 124 body or the 201. These numbers refer to different body styles. Currently, we have 4 body types, and you should become familiar with the number designations of each. Starting with the 190 class, the body style is known as a 201. The 300 body style is designated as the 124. The S-Class automobiles have a 126 body style, and the SL is referred to as the 129. Now that you're familiar with the nomenclature, let's look at each of our automobiles. While the 190E is described as a sports sedan, it's nothing less than a purebred Mercedes-Benz. With its multi-link independent rear suspension, this is one of the best handling passenger cars we've ever offered. It could, in the words of one automotive journalist, challenge some of the finest sports sedans in the world on just about any road you choose. The 190E is powered by a 2.6-liter inline 6-cylinder engine. This is a pure performance vehicle with an acceleration curve and driving performance that totally redefine the meaning of sports sedan. The 300 class of Mercedes-Benz automobiles is perhaps the most technically advanced in the world, offering a classic example of the Mercedes-Benz search for functional improvements wherever technological progress allows. We have never built a better handling sedan. It's a model of aerodynamics outside and a primer on intelligent human accommodation inside. This year, the 300 class sedans and wagons have a new look. The bumper area is larger, and we have added lower side panels. There is also more chrome on the outside to satisfy the taste demands of this segment of the market. Inside, you will find more wood trim than in last year's model. There's a new seat design in both front and back. We've added carpeting to the entire trunk compartment, including the lid for a more finished appearance. All of these changes are standard, on each of the 300 class automobiles, with the exception of the 300 CE Coupe, of which we'll show you in a moment. The 300 class is led by the 300E, with a 3-liter 6-cylinder engine, featuring 0 to 60 performance in 8.7 seconds. From its multi-link independent rear suspension to its anti-lock braking system, this automobile represents the leading edge of technology. The 300E 2.6 features a 2.6-liter engine, but gives little away in overall acceleration performance while retaining all the ride, handling, and quality of the 300E. For those who prefer a station wagon, you have the 300TE. Not only does it offer traditional Mercedes elegance with functional versatility, but the instant response and quickness redefines the concept of a luxury wagon. A new addition to the 300 class for 1990 is the 300D 2.5-liter turbo diesel. Like all the automobiles in this class, this automobile was designed to provide a high level of total performance and luxury appointments. Its 2.5-liter turbo diesel power plant adds all the economy and dependability that diesel enthusiasts have come to expect from Mercedes-Benz. To that point, you should know that the Mercedes-Benz diesel market is unique in the United States, with a history of loyal and dedicated customers. A diesel introductory video has been produced to reintroduce the diesel to the market, and we suggest that you take time to view it. It will provide you with most of what you'll need to know in order to talk knowledgeably with customers about our diesel engine technology. At the top of the class, you have the 300 CE Sports Coupe. Inside, you'll find burled walnut trim. There's a wood-trimmed storage compartment between the seats, and as with all our models, this year the steering wheel has been covered with leather. The customer also has the option of soft leather and door panel inserts to create an even more luxurious appearance. For 1990, the 300 CE becomes a totally different automobile under the hood. This nimble sports machine has been made even quicker with the addition of the new 24-valve 3-liter 6-cylinder engine. To be perfectly frank, this new power plant has made this an entirely new driving experience. We'll get into the specifics of this new engine in a few minutes. '90 also marks the introduction of 2 new automobiles in the 300 class, the 300E 4MATIC sedan and the 300TE 4MATIC station wagon. These 2 vehicles represent the first time Mercedes-Benz has offered its all-wheel drive technology in the North American market. One of the first things you have to understand about the new Mercedes-Benz 4MATIC is that it is more than a 4-wheel drive system. In a Mercedes-Benz, 4MATIC is really 2 things. First, it's a traction system designed to improve the driving dynamics of the automobile. Second, 4MATIC is a decision-making system that electronically monitors the road conditions. If those conditions change suddenly and there's need for better traction, automatically, without driver intervention, the system changes from rear wheel to one of 3 modes of all-wheel drive. Finally, 4MATIC is an information system that warns the driver that road conditions are slippery and 4MATIC has engaged. In sum, 4MATIC is different from any other 4-wheel drive or all-wheel drive system in that when you need it, it's there, automatically providing both important driving information feedback and, when needed, optimum traction and excellent directional stability, even under difficult road conditions. When it's not needed, you have all the benefits and superior handling characteristics of rear-wheel drive. We suggest that you take time to view the 4MATIC introductory video, which goes into some detail concerning how the system works. Your sales manager should have a copy on hand. The ultimate expression of Mercedes-Benz is to be found in the S-Class. From a powerful tradition of big Mercedes 6-cylinder automobiles comes the 300 SE. Powered by one of the most sophisticated engines ever produced by Mercedes-Benz, this S-Class sedan represents a remarkable combination of performance and drivability. The 300 SEL is 5.5 inches longer than the SE, which gives it more rear seat legroom. Powered by the same inline six-cylinder engine, it provides a gateway to the class with elegance, sophistication, and all the ample living space and creature comfort inherent in all the automobiles in the S-Class. In the 420 SEL sedan, you have a driver's car. The massive 4.2-liter V8 has proven itself to be one of the most capable engines available. Inside, the leather seat upholstery and hand-finished interior wood create an environment of tasteful elegance. The flagship of the Mercedes-Benz line is the 560 SEL sedan. Here, performance, comfort, and quality are blended into a sedan that stands above and apart from all others. The most sporting Mercedes-Benz models are the new 300 SL and 500 SL Coupe Roadsters, which, as I'm sure you know by now, have simply captured the imagination and praise of the automotive press. In your dealership, you have a copy of the SL introduction video, which we suggest you view at your earliest convenience. You'll find it will give you an excellent in-depth look at these extraordinary automobiles. Finally, the top of the class is the limited production 560 SEC Coupe. It is elegant, sporting, and powered by a 238 horsepower engine, which makes it one of the true performance leaders on the road today. Another new addition to the S-Class for 1990 is the 350 Turbo Diesel. This is the sister car to the 300 SEL and offers all the amenities and luxuries befitting an S-Class automobile, along with the proven performance and reliability that are inherent in Mercedes-Benz diesel engines. Again, as we suggested earlier, be sure to take time to view the 1990 diesel introduction video.
The best or nothing. 4 simple words, one uncompromising concept. This was the personal motto of Gottlieb Daimler, and it's the philosophy which guided Daimler-Benz then and which guides us now. This constant striving to improve our automobiles, the effort to push out the frontiers of excellence, is what differentiates Mercedes-Benz. It's the key to a price-value relationship which is unique in the industry. Unfortunately, many automobile manufacturers are trapped in what's called the commodity syndrome. They sell cars that, for the most part, are nearly identical to those of their competitors. It's a little like selling soap. One product is just about as good as another. There's simply no significant product differentiation. Just the opposite is true with Mercedes-Benz. We strive to differentiate our automobiles and to build the kind of value into our products that justifies the price. The key to Mercedes-Benz value lies in Mercedes-Benz Engineering. This is where we truly differentiate ourselves from most other automobile manufacturers. To help you appreciate this difference, we're going to provide you with a basic overview of the Mercedes-Benz engineering philosophy as it relates first to quality.
At Daimler-Benz, one of the major principles is that quality must begin with design. It is a fundamental fact that there is simply no way you can test quality into existence. It must be designed into each vehicle and then built in through precise and controlled manufacture. Quality design begins with research, and research exists to refine current designs and to provide the information necessary for improving future designs. Together, research and design are interrelated phases of the ongoing evolution of quality. Research at Daimler-Benz ranges from the exploration of ideas in a computer-driven simulator to the test of prototype models in many different laboratories and on road courses. In many instances, laboratory tests are designed to simulate many thousands of miles of driving over the worst possible road conditions. The test track also serves as a research laboratory. Its purpose is to permit engineers to test suspension, steering, braking, and overall handling and performance characteristics on different surfaces and under controlled conditions. One of the research devices used at the track is the so-called driving dynamics car, or test mule. Through use of its quick-change body parts, the Mule can be used to simulate a wide variety of vehicle characteristics, including body weight distribution, suspension load, and wheelbase. While all of these tests are fundamental to the creation of the end product, possibly none is of greater importance than the ongoing research involving safety. Every year, approximately 100 crash tests involving almost fully assembled cars are crashed in a variety of simulated accidents in the Safety Research Center. The purpose of these tests is to help Daimler-Benz engineers better analyze the effectiveness of their automotive structures and components under a variety of conditions. From these and other research projects, a steady stream of information is developed to be utilized in decisions affecting future designs and manufacturing specifications for every one of the 50,000 or more parts and components that together create a Mercedes-Benz automobile. With the quality designed in, the next task is to be sure that every component and part meets the rigid specifications. This is where the quality control testing and checking begins, and it's a methodical, exacting, and never-ending process. Even components as basic as seats and electric windows are subjected to ongoing endurance tests. Every Mercedes-Benz passenger car engine is manufactured at our Untertürkheim facility. The daily production can reach approximately 3,000 engines. Here, Daimler-Benz builds engines for every market need. All told, we can build 1,500 different engine types. One of the primary areas of interest is the engine test room, where 55 testers working in 2 shifts are given the responsibility of subjecting each and every engine to a function test. This is a computer-controlled test that checks every major function. Once this test is complete, a percentage of each day's engine production is tested at varying loads for a period of 4 hours. Finally, a number of these engines are dismantled completely, and each part is carefully analyzed and inspected. The entire process, from teardown to component check to rebuild, can take up to a week. 100% of the automatic transmissions are tested on 12 computerized test benches. These devices have the ability to collect 4,000 different data points in just 2 minutes. Each automatic transmission is subjected to a 6-minute test run and evaluated against established values. Before the rear axle with independent suspension is assembled, the differential is tested on computer-controlled benches. Noise levels, which can signal the operational exactness of the components, are monitored both by special equipment and by trained technicians. In the wood shop, skilled craftsmen give the expensive wood a veneer finish that would do credit to the finest furniture. Here, the quality checks are mostly aesthetic. Each piece must look as if it belongs in a Mercedes-Benz. The seats are built by experienced hands. The foundation is a tuned steel spring base. Layers of natural fiber and foam padding are added to create an orthopedically correct seat and to enhance airflow. The purpose, of course, is to provide drivers and passengers with firm support to help reduce fatigue during long drives. The seats are then covered with the finest leather or a special leather-like material called MB-Tex. While this certainly adds to the ambience of the interior styling, it's the workmanship that creates the ultimate quality. At the end of the seat building process, each seat is examined, tested, and given an individual stamp of approval. Unlike many manufacturers, Daimler-Benz produces the majority of its stamped body parts and sections at the same facility where many of them are finally assembled. This helps ensure constant dimensional uniformity because the on-site quality control procedures can identify deviations immediately and correct them. To that point, in the stamping plant, every 150th stamped part is checked. A typical inspection involves cleaning the part and giving it a visual and hand inspection. The part is also sanded by trained experts to reveal any imperfections or waves in the metal. The next step is assembly, and that begins here with the creation of the body in white. The unitized body shell is assembled with between 4,700 and 5,600 spot welds, depending upon the model. The Mercedes-Benz engineers see the combination of manual welding and robot welders as the optimum in terms of assuring the highest quality assembly. Numerous measuring and monitoring systems, ranging from human hand and eye checks to computer-assisted inspection, are fundamental to quality control and to obtaining objective data on the manufacturing process. One of the major measuring activities takes place at the Flexible Body Measuring Station. Here, 2 large robots make 648 separate body measurements in about 40 minutes to assist in the dimensional fine-tuning. They also are used to check trends and to call attention to any deviations in tolerances. In another area, 2 cars per day are taken from the line and, depending upon the test program selected, are subjected to as many as 1,000 measurements. The purpose is to both monitor the manufacturing operation to see if any deviations from specifications occurred, and to provide the data necessary for establishing new model tolerances. The door fit tolerances are exact to 0.5 millimeters. One interesting point to note is that unlike many other manufacturers, we do not use shims to adjust door clearance. The hinges are set on an X and Y axis adjustment so as to assure a better door fit. Throughout the manufacturing process, a quality control inspector assigned to each assembly operation group is responsible for inspecting and approving the work before the car moves on. The inspector puts a personal stamp on the control card to show that he or she has personally inspected the work or task. Thus, every vehicle has a documented quality control history. A major objective at Daimler-Benz is to create automobiles that both resist corrosion and maintain a high-quality, durable exterior appearance. In all our vehicles, the corrosion protection program begins with the use of galvanized steel panels in areas of high potential exposure. About 45% of the body in white weight of our cars consists of galvanized sheet metal. Once the body in white is ready, the surface is degreased and phosphated and then sent to the cataphoretic dip for priming. Daimler-Benz has used the cataphoretic dip priming system since 1979. This permits the use of highly corrosion-resistant epoxy resins, which lead to improved long-term corrosion resistance. After cataphoretic dip priming, seams and crimped parts prone to corrosion are sealed with a PVC substance to repel water and dirt from those areas. After the intermediate chip-resistant coating, the entire body is primed. The last step of the protection process involves coating the body cavities and inner surfaces with a special anti-corrosive wax. This final process provides a measure of extra protection. As the body moves on toward final assembly, the assurance of quality becomes more and more the responsibility of the individual workers and quality assurance inspectors. While there is some robotic assistance, as in the insertion of the fuel tank, most of the task involves skilled handwork. At each step of the way, individuals check the work, and only when they are satisfied that it meets Mercedes-Benz standards do they add their mark of approval to the quality log. By the time a Mercedes-Benz is ready to be driven off the production line, it has been inspected nearly 350 times. Very clearly, it's the people here, their dedication to excellence, and their commitment to building the world's finest production cars that, in the final analysis, separates our automobiles from those of our competitors. Quality by design, standard in every Mercedes-Benz automobile.
Let me add a few thoughts on our design philosophy. In designing a Mercedes-Benz, form always follows function. When changes are made in Mercedes-Benz styling, it's because an engineering function has dictated the change. A specific case in point is engineering aerodynamics. In most of today's advertising, manufacturers relate aerodynamics to fuel efficiency, and certainly this is a benefit of improved aerodynamic design. While we're concerned with fuel efficiency, we're also concerned with the impact aerodynamic achievements have on general safety, handling, stability, visibility, and noise levels.
For example, the contours on the side of the car may appear to be no more than a styling decision. Quite the contrary, it is the result of a functional decision. The reason is that by carefully shaping the side contours of the car, the engineers have significantly reduced the effects of side winds that can jar a fast-moving automobile from one side to the other. Another example. All Mercedes-Benz automobiles use airflow management to increase the downforce on the front axle, countering the front end's tendency to lift as speed increases. This results in increased stability at higher speeds. These are just two of the aerodynamic benefits incorporated into the design of the car. There are many more. The main thing to understand is that in our engineering philosophy, the function determines the form. To put it another way, the look of a Mercedes-Benz is not just the creation of a clever stylist, but the sum total of hundreds of engineering design decisions. Mercedes-Benz engineering philosophy is reflected in body structure design. Our safety criteria call for a rigid passenger shell to help protect the occupants in the event of an accident. At the same time, it has to be light enough to contribute to overall fuel efficiency. We pioneered what's known as the monocoque body. This is a single structural unit that offers exceptional rigidity. Virtually every major manufacturer has followed our lead in this area. However, in striving for the best body, we employ up to 6 types of metals, including a high-strength, low-alloy steel that is significantly stronger than conventional sheet metal. The result is greater structural strength, less weight, and more corrosion resistance. The engineering philosophy that governs our suspension systems is one that at first seems contradictory. We want all our cars to have the agility and nimbleness of the single-purpose sports car, yet still retain the smooth, comfortable, stable ride that's associated with the luxury sedan. The secret of the Mercedes-Benz dual personality lies primarily in the type of suspension employed by the engineers. Every model benefits from a fully independent suspension. The specific design may vary from model to model, but the results are the same. The main advantage of a fully independent suspension is the ability to allow each wheel to react independently to every bump and dip without affecting any other wheel and without transferring the jolt to the body. Fully independent suspension also improves handling responsiveness by keeping the maximum possible tire surface on the road at all times. When one wheel is kicked up by a bump, the other 3 remain in firm contact with the road surface. Our 5-link rear suspension design permits the rear wheels to move through a controlled, predictable pattern so that bumps or lateral forces create minimal impact on steering control. When it comes to the interior of a Mercedes-Benz, the engineering philosophy is guided by safety, which we will discuss in detail later, and by the science of ergonomics. Ergonomics is the science of making man and machine more compatible. As you sit behind the wheel, you begin to understand how that translates to a Mercedes-Benz. All the controls fall easily to hand. You don't have to lean forward to turn on the radio or adjust the climate control. Everything is within easy reach. When it comes to the seats, you'll find them firmer than those in most cars. The reason simply is because a firm seat can provide more orthopedic support. This support helps minimize physical fatigue during long drives, which helps keep the driver more alert and at the same time can provide greater lumbar support.
While the best or nothing is our philosophy, the passion for safety is our commitment. To tell this story, we produced a special video called Safety by Design, which you should have in your dealership video collection. You may find it useful in explaining our safety story to customers. Of all the many benefits Mercedes-Benz offers the owners of its automobiles, possibly none is more important or ultimately of more value than its ongoing commitment to safety engineering. The result? Mercedes-Benz levels of safety have set standards that are respected throughout the entire industry. Fortunately, most of you will never need to call on the safety features engineered into these automobiles. However, there's a lot of comfort in knowing that they are there just in case. When the experts talk about automotive safety, they do so from two different perspectives. First, there's passive safety, which is defined as the ability of the car to help reduce occupant injuries in the event of an accident. The other component is active safety. This refers to the ability of the car to help the driver avoid accidents. While these definitions apply to all cars, we feel it is the execution of the concept that distinguishes Mercedes-Benz. Let's start with passive safety. One of the keys to reducing passenger injury is to create a body structure which has the ability to absorb and dissipate significant amounts of the energy created by a collision. Almost 40 years ago, Mercedes-Benz engineers pioneered the concept of front and rear deformation zones. As demonstrated in these slow-motion film recordings of crash tests at our safety center, the front and rear body sections are designed to progressively yield to the force of a major impact. In this way, they dissipate energy in order to help avoid intrusion and to reduce the impact load transmitted to the passenger compartment. In addition, you'll find that the A-pillar has been combined with a rigid cabin structure which gives it the ability to deform yet resist crushing in the event of a rollover. As you can see, the roof structure is able to resist collapse. Here's an even more dramatic example. In this test, the automobile is dropped directly on its A-pillar at a compound angle. Again, the roof structure is able to withstand the impact. In the rear, you again have deformation zones to help absorb the impact of a collision. To reduce the risk of a fuel tank rupture, in our sedans and coupes, the tank is placed over the rear axle and as far from the rear bumper as practical. And by placing the spare tire horizontally in this well, we add a further deformation barrier and at the same time increase the trunk space. Even the door handles and locks are part of the passive safety system. They've been designed to stay closed on impact and then to be opened afterwards. By using a pull handle, a person outside the vehicle can get better leverage when opening the door. In addition, the sedan doors have been designed with a lip so that in the event of an impact, one will ride up over the other to reduce the possibility of jamming. Passive safety is also a major consideration inside the passenger compartment. There's padding on the door pillars, the dash, and on the gear shift. Notice the absence of knobs. All the controls are rounded and mounted flush whenever possible. The rear view mirror has a mounting designed to break away on impact. Even the wedge-shaped seat cushions play a part in passive safety. They've been designed to help prevent passengers from sliding or submarining forward and under the seat belts during an impact. In the 190 and 300 classes, a ramp-shaped squab beneath each seat augments the cushions and helps absorb impact energy. And here's a further illustration of Mercedes-Benz attention to detail. If you were to pry off some of the wood trim from the console or dashboard, and we don't suggest you do this, you'd find that the wood is laminated in thin layers with aluminum sheets. The purpose of this type of construction is to allow the wood to bend and help to prevent splintering in a collision. Now, while things like this help illustrate the Mercedes-Benz commitment to safety, the heart of our interior safety system is found here, and in the three-point seat belts for the outboard passengers in the back seat. And by the way, permit me to remind you that the proper use of seat belts, both front and rear, and the use of child restraint seats for small children is a safety must. Now, while seat belts have become a standard feature in all automobiles sold in this country, Mercedes-Benz has gone a step further and added an emergency tensioning retractor, or ETR, to the driver and front passenger seat belts. If the automobile should become involved in a major frontal collision, the ETR is designed to instantaneously and automatically tighten the three-point seat belts, holding the occupants in place and restricting forward movement. Also standard on all Mercedes-Benz automobiles is the Supplemental Restraint System, or SRS.
This consists of a driver's side airbag, knee bolsters, and emergency tensioning seat belts. The passenger side airbag is standard on all V8 S-Class models and the new SLs. The other S-Class models and the 300 class vehicles offer the passenger side airbag as an attractive option.
In the event of a major frontal impact, a sensitive electronic device triggers the airbag, which inflates fully within just milliseconds, cushioning the head and upper body and minimizing the risk of contact with the steering wheel. The airbag then immediately deflates so that the driver's view is unobstructed. Simultaneously, of course, the emergency tensioning retractors tighten both front seat belts. The entire sequence takes less time than the blink of an eye. In active safety, there are three key elements that impact the driver's ability to avoid trouble before it happens. They are visibility, comfort and convenience, which, as you'll see in a moment, has more to do with safety than you might have realized, and the automobile's performance characteristics, namely handling and braking. When we talk about visibility, we're talking about the driver's ability to see and be seen. Outside, visibility means good lighting. Even powerful halogen headlamps are not going to perform as well if they're covered with road dirt. That's why on certain models you'll find headlamp wipers and washers. And speaking of washers and wipers, the windshield washer nozzles on all models are automatically heated to prevent icing. And on the 190 and 300 class models, this eccentric sweep windshield wiper clears 86% of the glass area, which is more than any other car Mercedes-Benz has measured. Inside of Mercedes-Benz, you'll find that you have excellent all-round visibility. During rainstorms, this visibility is maintained by channels in the roof pillars, which help divert the rainwater away from the side windows. There's also a special molding back here, which serves the same purpose for the rear window. And when the temperature approaches freezing, electrical heating elements in the side view mirrors are automatically activated to prevent fogging and icing. The padding on the dash and instrument panel is a dark color to minimize reflection and glare in the windshield. In the 300 and S-Class models, you'll find a third sun visor over the rear view mirror to reduce sun glare. The stalks that control the high and low beams, turn signals, wipers, and cruise control are designed for fingertip control and can be operated without taking your eyes from the road or your hands from the wheel. Plus, we use circular and semicircular gauges with analog numbers because research has shown these are the quickest to read and easiest to understand. Most people don't think of safety in relation to comfort and convenience. Yet we all know that fatigue and discomfort during long drives tends to make us less alert and can affect our driving performance. Mercedes-Benz has put a lot of effort into helping drivers minimize the factors that cause fatigue. For example, the firm orthopedically designed seats are built on a tuned steel spring base foundation. Layers of natural fiber and foam padding are added to create an orthopedically correct seat. The purpose is to provide firm support to help reduce fatigue during long drives. The seats themselves are fully adjustable to make it easy to change the tilt, height, back, and headrest positions. The entire passenger compartment is sealed against engine noise and heat. Even the airflow through the automobile is designed to provide a continuous supply of fresh air to help the driver stay comfortable and alert. The third element of active safety is the handling and braking performance of the automobile in emergency situations. If it should become necessary to make a sharp and sudden evasive maneuver, the power-assisted recirculating ball steering precisely translates the driver's steering input to the front wheels. What this does is help put more directional control in the driver's hands while maintaining excellent steering feel. Add to this the sophisticated suspension design of each model, and the result is better traction, more control, and greater stability. Notice how in this test track evasive maneuver demonstration, the Mercedes-Benz seems to snap back in line after the sharp turn. When it comes to braking, Mercedes-Benz provides two-circuit hydraulic four-wheel disc brakes. In normal braking situations, the large diameter disc brakes help bring the automobile to a controlled, straight-line stop. But because some situations demand more than normal braking in order to avoid an accident, Mercedes-Benz helped pioneer what's been called by many the single most important advancement in automotive safety, ABS, the anti-lock braking system. Consider this situation. A driver is rounding a curve and comes upon sudden trouble. The natural instinct is to slam on the brakes. Without ABS, the car acts more like a sled. The wheels lock up, and the driver loses the ability to control the car. Now the same situation, but this time with ABS. As soon as the driver slams on the brakes, the ABS system automatically begins working to prevent wheel lockup. As a result, the driver can brake and maintain steering control at the same time. Here's another test simulating a combination of ice and wet pavement. Without ABS, hard braking throws the car into a partial spin. With ABS, the brakes are applied and the car comes to a safe and controlled stop. Here's how it works. With the driver's foot hard on the brake pedal, the system senses wheel lockup. When this occurs, sensors relay this information to an onboard computer which controls the automatic pumping action of the brakes. This electro-hydraulic modulated braking action can occur as often as 15 times per second. Without question, anti-lock braking has redefined active safety. At Mercedes-Benz, safety begins with the idea that a luxury automobile must offer more than style, engine performance, and interior comforts. It must deliver a package of capabilities designed to help the driver cope with most highway emergencies. It must provide a combination of safety systems and structural integrity whose combined purpose is to help reduce the possibility of serious injury in the event of an impact. As we view it, safety is not a luxury, but a commitment. And it is through the ongoing pursuit of this commitment that we have redefined luxury as the comfort that comes from knowing that in a Mercedes-Benz, safety is by design. This brings us to the last item on our list, the power plants. Once again, the best or nothing is the guiding philosophy. We build two different kinds of engines, gasoline and diesel. For 1990, we offer 6 gasoline engines and 2 diesels. Each is matched to a specific automobile in the model line, and each reflects the basic character of the model it serves. Possibly the most important thing to keep in mind when talking about a Mercedes-Benz diesel engine is that we build our engines from the ground up to be diesels. Now, this may sound like an obvious statement, but the fact of the matter is that in the past, certain manufacturers attempted to convert their gasoline engines to diesel operation with unsatisfactory results. The reason is that the gasoline engine is designed to handle compression ratios of no higher than 10 to 1. Whereas the diesel engine operates at a compression ratio of approximately 22 to 1. For that reason, diesels require stronger internal components such as pistons, connecting rods, crankshafts, and cylinder heads.
The Mercedes-Benz diesel tradition dates back to 1936, when we introduced the first production diesel engine for automobiles. What followed were 50 years of constant technological improvements, including such innovations as turbocharging. Then in 1987, Mercedes-Benz decided to suspend production of those diesels with a trap oxidizer emission control device. This is an advanced diesel emission control device for the reduction of particulate matter emissions. The decision to temporarily halt production was due to certain problems which might have possibly led to premature turbocharger wear. Now, in 1990, with the problem eliminated, Mercedes-Benz announces two new diesel engines, the 2.5-liter and the 3.5-liter turbocharged diesels. Both these engines offer a marked reduction in exhaust emissions. In addition, they continue to offer the special characteristics that have become synonymous with Mercedes-Benz diesels, namely low fuel consumption, longer than average service life, excellent refinement and comfort, and no perceivable issue of smoke from the exhaust pipe. Turning to our gasoline engines, the first in our line is the 2.6-liter inline six-cylinder engine, which delivers 158 horsepower and 162 pounds-feet of torque. It is available with either a 5-speed manual transmission in the 190 class only, or a 4-speed automatic, which you'll find in both the 190 and 300 classes. The second gasoline engine is the 3-liter inline six-cylinder powered engine. This engine produces 177 horsepower. It has electromechanical KE5 fuel injection. It is a proven injection system which measures the air entering the engine and at the same time electronically fine-tunes the mixture of air and fuel to help assure peak performance and minimum emissions under all types of load and weather conditions. Next, we have two V8 engines. The first is a 4.2-liter with single camshafts over each bank of cylinders. It has electromechanical KE3 fuel injection along with electronic ignition. This is a microprocessor-controlled system that determines the best and most precise ignition times for maximum power output and fuel efficiency. The 5.6-liter V8 incorporates the KE3 electromechanical fuel injection system, which is a blend of mechanical reliability and electronic precision. You should know that Mercedes-Benz pioneered the fuel injection principle itself in production automobiles more than 3 decades ago.
The big news for 1990 is the introduction of two multi-valve gasoline engines. One is the 3-liter 24-valve six-cylinder, the other is the 5-liter 32-valve V8. The goal in designing these engines was to create power plants that would provide more power and quickness. One of the first and most obvious differences between the current 6 and V8 cylinder engines and the new engines can be found in the cylinder heads. Mercedes engineers have added one intake and one exhaust valve per cylinder to the cross-flow design.
Obviously, with more valves, you need more camshafts. Here on this V8, you see the 4 overhead camshafts, one for intake and one for outlet on each bank of cylinders. These are driven by this double roller chain. One of the important innovations to be found in this engine is the use of an electronically controlled adjustment to the intake camshafts. What this does is permit the engine to vary the valve timing to compensate for speed, load, and torque. As compared to conventional valve operation, this design offers several advantages. It improves cylinder charging, which works with the cylinder heads to create higher torque values, which create a simultaneous decrease in pollutant emissions.
One last thought. Many of your customers consider themselves experts when it comes to Mercedes-Benz. You'll go a long way toward winning their confidence and their business if you can demonstrate that you're the product expert they expect you to be.